This set of notes is going to cover information on the water cycle and also humidity and water vapor. So, as far as the water cycle goes, it's just as it sounds. It's water that's getting cycled through the atmosphere and Earth. So, water never really leaves Earth. All it does is it gets cycled through the different forms of water, like ocean, even land, and then up through the atmosphere, and the cycle just continues. The process is known as the water cycle, and it gets its energy from the sun. So in order for water to turn from liquid to a gas, it has to evaporate, and it has to have heat to evaporate. So the sun provides that energy to change the water in the different forms. The water cycle is crucial to the existence of life on our planet. This visual shows you what happens in the different stages of the water cycle. It shows you that from the water that's stored in oceans, the sun can heat it up, it'll evaporate and condensate to make clouds, and then it'll come out in the form of precipitation. It can run down mountaintops, it can seep down into the soil, and then get stored back into another water source and evaporate and start all over again. The first stage of the water cycle we're going to talk about is evaporation. You can see from the circled areas that evaporation is something that is going to happen from the sun, and it happens whenever water gets heated up. So specifically during this part of the water cycle, the sun is going to heat up the liquid water, and it's going to change it into a gas by the process of evaporation. That water that evaporates from the oceans and the lakes and the rivers, it will end up rising up into the atmosphere. The next stage of the water cycle is transpiration. You see here it's circled by the trees, letting you know that transpiration is something that's going to happen with plants and trees. The process of evaporation from plants is called transpiration. So we just talked about how evaporation is when the sun heats up water in a body of water and it turns into a gas. Well, transpiration is the same thing, except for it's specifically through plants and trees. So whenever water flows from the plant's roots or through the leaves, it gets on top of the leaves and then it evaporates up into the sky. So in other words, it's pretty much like the plants are sweating. It loses that water, the water gets heated up, and it turns into a gas. The next stage of the water cycle is condensation. You can see in the circled diagram that this is going to be your stage after evaporation, and it's where the water vapor ends up forming clouds. So as the water in the form of a gas rises higher in the atmosphere from evaporation, you know that you get higher up in the atmosphere and it starts to get colder. So this gas that was heated up now starts to cool down and becomes a liquid again. This is called condensation. So whenever a large amount of water vapor ends up condensing, it's going to result into the formation of clouds. The next stage of the water cycle you can see circled is precipitation. Precipitation occurs whenever the clouds that are formed during condensation get too heavy and they release the water in the form of a liquid or a solid. So when the water in the clouds gets heavy, it falls back down to earth through the cycle of the water cycle, and it falls down in the form of rain, snow, sleet, or hail. That's called precipitation. The next stage is runoff, and this happens whenever the clouds release their form of precipitation and whenever this water or rain is going to run off the side of a mountain or run off land. Whenever the soil is just too full to hold water, it's going to start the stage of runoff. So when the rain falls on the land, some of our water gets into the soil. That's called infiltration. So if you've heard of anything like somebody infiltrating the camp when you learn about social studies, that's like someone seeping into or coming into the area. Infiltration, as far as the water cycle goes, is whenever water seeps down into the soil. It gets infiltrated. The soil gets saturated and it absorbs all the water into the ground. And whenever all the water gets into the ground, it forms pockets called groundwater. So groundwater is whenever the water gets down into the soil and starts to form pockets of water. So most groundwater eventually returns to the oceans, but sometimes the precipitation is going to run directly into the streams or rivers whenever the soil gets too full. So if the water ends up seeping down into the soil and the soil is holding as much water as possible, then it can't hold anymore and the water will end up running off of the surface, and this is called runoff. So this is just a really easy visual that shows you a bunch of different stages of the water cycle. It's all powered by the sun. The sun is giving energy for evaporation, which ends up going up, condensation, making clouds, precipitation, the rain coming back down, and going back to the water sources. This visual is a very important visual that's going to show you guys a lot about where you're going to find the majority of water vapor. You see at the poles it's purple, and on your key purple stands for 0, so a very small amount of water vapor. And you see that the majority of your water vapor is around the center area of the globe, which is by the equator. That's because warm air can hold more water vapor than cold air can. And because there's more water vapor in these regions, you're going to see more precipitation. So what exactly is the relationship between temperature and water vapor? So as the temperature climbs and increases, the amount of water vapor also increases. So I told you in the last slide that warm air can hold more water vapor than cold air can. So at higher temperatures, there can be higher amounts of water vapor in the atmosphere. Near the poles, we talked about how those are our colder areas, so the amount of water vapor is going to decrease because of our low temperatures. The next thing we need to talk about is dew point. Dew point is the temperature at which water vapor is going to start to condense out of the air as liquid water. Several of you have heard forecasters when they talk about the weather, they talk about the dew point. That's the point in which dew starts to form on, your grass outside or trees. So dew point is just that temperature where water vapor is going to condense and turn into liquid. Relative humidity is the actual percentage of water vapor that's in the air compared to the maximum amount of water vapor that the air can hold at a particular temperature. Okay, so relative humidity is all about water vapor, and it's going to be a percentage of how much water vapor is in the air versus how much it can really hold. So if you look at your picture, it shows you the desert with low humidity, and it shows you a rainforest with high humidity. The first picture shows the amount of water air holds at 10 degrees Celsius, which is very little. You don't see any little hue around that water vapor droplet. Then it shows you the amount of water that air can hold at 20 degrees Celsius. So it's starting to heat up, and you see that there's now a little yellow area around that water vapor, which shows that it can hold more water vapor. Now it's getting even hotter in the third picture, and that shows you the amount of water that air can hold at 30 degrees Celsius. So it shows you that as the air heats up, it can hold more water vapor. And this is where I got some of my sources. That's all I got for you.